Hi there, Year 8. So today we are looking at wave calculations. Now before you get all upset that it's all mathsy, just remember it's just times and dividing and you are allowed a calculator. We're going to go through a few of these and you are allowed to, if you are feeling really confident, you don't have to watch every single video. I would like you to watch this first one though. So, wave calculations. So, what we need to know is we need to know three different things. We need to know, well, we only need to know two. We're going to calculate the other one. One of them is the wave speed. And because it's speed, we measure it in meters per second. And we use the letter V to represent speed, V for velocity, okay, because S is obviously seconds. So we use V for velocity. Okay, the next thing you need to know is the wavelength, so how long the wave is. Okay, so if I just grab my little slinky here, okay, now if you remember, if a wavelength is from peak to peak, so the top of a wave to the next one. Okay, so if my slinky were a wave, okay, I've got the top of the wave to the next one. Okay, so that would be one wavelength. And obviously, we could make those wavelengths longer or we can make them shorter. Okay, and we measure wavelength in meters. Okay, so the wavelength is measured in meters. The last one is the frequency. And the frequency is how many waves go past a fixed point in time in 1 second. Okay, so if this is the fixed point, if we've got our waves spaced out, okay, you can see that not many are going past. It's got a low frequency. On the other hand, if we've got our waves all close together, it's moving at the same speed, but lots more waves are going past my fixed point in that 1 second. It's got a high frequency. So the way I remember it is low frequency, long wavelength, because both the words start with similar sounds, the LO. So low frequency has a long wavelength. Okay, and high frequency has a short wavelength, but that kind of doesn't lend itself to remembering it very easily. Okay, so how do we do this as a calculation? Obviously, our wavelength and our frequency are linked because as one goes up, the other one goes down. They are inversely proportional. We say, do you remember the word proportional from doing our Hooke's law experiment? It means as something goes up by a set amount, the other one goes up by the set amount. If I'm buying a chocolate bar for 50p, 2 chocolate bars is £1. 3 chocolate bars is £1.50. It goes up 50p each time. If inversely proportional is the other way round. So if I am, for every chocolate bar I give you, I lose a chocolate bar. You get 1 chocolate bar, I lose a chocolate bar. Okay, so as one thing goes up, the other thing goes down. So these two are inversely proportional. Now what we're going to do is we're going to just take a quick look at the sums in the book. Okay, so I would really recommend you copying this down. This is what we've just gone over. Wave speed, or V, is in meters per second. Wavelength, or lambda, that's the thing that looks like the upside down Y, is in meters. And frequency, or F, is in hertz, which is capital H, small z. How do we do it as a sum? Here we go. Here's our triangle. So we have got speed at the top of the triangle. So if we cover up our speed, I'm just going to use my thumb to cover it up. There we go. We are left with wavelength multiplied by frequency. Okay. If I wanted to find out the wavelength, let's cover up the wavelength. I've got speed divided by frequency. And let's just switch hands. If I wanted to find out the frequency, let's cover up the frequency. There we go. And refocus this. I have got wave speed divided by wavelength. Okay, let's just refocus this. There we go. So frequency is wave speed divided by wavelength. You might want to write down this triangle as well, because you will be using it in the sums in the following videos. You will need all the information from this video to answer the first 10 questions. Off you go.